Why doesn't India make its own chips? And can it one day? To discuss, I have on the show today Pranay Kotasthane. He began his career as an IC designer who worked at Qualcomm and TI, then left the field to join think-tankdom. He's currently the deputy director at the Takshashila Institute and most recently co-authored a book called The Chips Are Down, an exploration into the geopolitics of semiconductors. Co-hosting today is Chris Miller, a guy who also knows a thing or two about the history of chips. Welcome to ChinaTalk, you two.
Thank you, Jordan and Chris. Great to be here. I've been reading a lot from both you guys, so great to be here on the show.
I think we want to turn the clock back maybe to the 70s or 80s. Over the past 40 years, India has emerged as a powerhouse of software, not hardware, design, not manufacturing, which is a different tack than the one than the arc that China has been on in the latter half of the 20th and into the 21st century. Pranay, as a student of history, why don't you start us wherever you think is most relevant, and let's do a little extended tour of what has and hasn't worked from the perspective of manufacturing versus more software-oriented industries.
In general, we have to see the history of India's economy to be able to understand this. And we need to know that before 1991, there was no economic liberalization, and largely it was the state that was supposed to do a lot of things, even in technology areas, right? So the let's understand it from the internal context and the external context. So the internal context was this: largely the government had a prime role in all the industries, whether it is steel, space, semiconductors, whatever, right? And it is not very dissimilar from what you would see in the USSR and in China as well, pre 1978. So all these three were similar, and it's not surprising that the state run semiconductor efforts of all three failed. And I draw some parallels between the three. So that was the internal context. The external context was that India also had many technology denial regimes on it because it was seen to be close with the USSR during the Cold War era. So there was also denial of technology from which was sensitive, right? So including computers, etc. So you had what resulted out of this is that the state took upon itself to do many things on the technology front. It achieved some success on space and a very limited success on defense areas. Also, it did achieve some success on nuclear. So, what it tried to do is implement the same kinds of steps even in the semiconductor domain. So, you see exactly what India tried to do in space, and nuclear was applied to the semiconductor domain, and this is how it went, right? So, I call this era's semiconductor efforts as by the government and for the government. And the reason for this was there were, as I said, there were just two government run companies, both of them, which started to do something in semiconductors right from the 1950s. So there was one company called the Semiconductor Complex Limited, SCL. It is a government enterprise in Chandigarh, and it started producing chips using 5 micrometers CMOS in 1984. No, and because it had government backing, it also had a good pool of graduates, PhDs, etc., from India's top engineering colleges. So it was able to do that pretty decently. And over time, it moved by the late 1980s, etc. It also got some technology transfer from an American company called Microsystems Incorporation. And then it also had some collaborations with Rockwell and Hitachi, etc. So over the years, it moved to 800 nanometers CMOS, and it was a few years behind the global cutting edge, never leading, but it was not that bad either. But what you see thereafter is that it couldn't graduate to producing large scale commercial chips, which were really the trendsetters in advancements of semiconductor manufacturing during that time, right? And during that time, you also it started hitting the limits of the Rock's law, which we always talk about, how capital cost of fabs almost doubles every 4 years. So, because it was a government run company, no incentive to invest in a large amount of money to produce chips for exports, right? That's not what government companies are supposed to do. They are supposed to be economical, they are supposed to preserve the precious foreign exchange which existed at a time of capital controls pre 1991. So there was no mindset that you need to grow really big and succeed. So that was what happened, and eventually it fell behind. By the 2000s, what happened was the SCL just was producing very niche chips for these space and nuclear domains. It was not working on the commercial chips. And thereafter, it sort of declined. It was taken over by the Department of Space. And only recently, it has gone back to the Electronics Ministry. Now there is talk of actually reforming it and putting it into the private domain. So that's what one company did. The other parallel effort that was going on is Bharat Electronics Limited, BEL. This was again a government sector company which was started way back in the 1950s. It started doing germanium transistors way back in 1959. And in 1962, it also had technology transfer from Philips, etc. And it manufactured its first transistor, etc. At in its heydays, it was manufacturing nearly 20 million transistors. And by 1980s, it also started moving towards ICs. Okay, so again, the good thing was that it did get some technology transfer after a long time. So in fact, it got technology transfers from RCA also, right, which eventually led to technology transfers in Taiwan and TSMC as well. So there were similarities in that sense. But again, what you see is a similar story repeats. It starts manufacturing something, gets ahead, but then there is not much capital investment which comes in, and it falls behind progressively from other companies. And over time, it keeps manufacturing only for the limited government space.
So why don't you sort of compare the arc that you saw with these two sort of like semiconductor national champions to the aerospace industry and the vehicle industry? Like were there broadly similar stories that were happening as in India's other efforts to build to build itself into a manufacturing house or powerhouse, or were there particular challenges within the semiconductor industry that led to these underwhelming results?
Yeah, that's a great question. The story depends on the sectors that we are talking about. So, for example, India does quite well in automotives. It does export a lot of cars, not the electric ones as yet, but we have a very good two-wheeler industry and a four-wheeler industry. Now, the unique thing about the automotive industry was earlier efforts failed. Similarly, there was a government-run company, etc. But the government-run company was started because the prime minister had special interest in it. Her son wanted, literally ran the company, which was Maruti, etc. So there was a lot of political capital invested in getting it off the ground. In fact, there were special exemptions made to this company so that it could collaborate with foreign companies, take technology transfer easily, import a lot of components which go into making automotives, etc. So that kind of drive wasn't there in some of the other sectors. So that is one section. Now, space is one thing where India did succeed, and you would have heard of Chandrayaan, etc., landing on the south pole of the moon recently, etc. Now, in space, the story that you see is because the buyer was largely the government. They never had to look at major capital expansion of the kind that you need in semiconductors. So, just to give you an example, the entire budget of the Department of Space even today is less than $1 billion, right? So whereas the latest Arizona TSMC fab is what, $12 billion to begin with. So that just gives you how different the two sectors are. So in the sectors where the demand was small, space and nuclear, you could indigenize technologies by getting a smart bunch of people, scientists, quickly learn the technology through some transfers and then innovate over time. But that was not the case in semiconductors, as we know, because the demand is different, capital costs required are different, the buyers are the whole world. You need to keep investing repeatedly. So, because of this sort of sectoral differences, the strategy that worked in space didn't work in semiconductors, whereas for automotives, it was a completely different, unique story.
Gotcha. Yeah, I wrote a Fulbright application to study Maruti, Japan, which I think the State Department very smartly rejected back in like 2015 or whatever. But it is a really interesting story because you had, the Indian government make this special exception. You had sort of like Japan India relations like riding on this one story, which, like, what ended up being a moderate success, even though you have the sun running it and all this mess, because there was so much energy and excitement, and I guess so much pressure on this firm to really deliver.
Yeah, I wish he were interested in chips at that time. Maybe then we would have had a semiconductor industry as well.
So, an interesting point you make in your book, Pranay, is this idea that TSMC and the Indian competitors were almost like starting at the same, almost like at the same starting blocks. Chris and Pranay, I'd love to hear you sort of like compare and contrast on, what ended up allowing, what Taiwan had going for it that India didn't at the time.
Well, I think that's a great question, and it's not only India, it's also Singapore as well, had a Chartered Semiconductor was founded also in 1987, same year as TSMC. Now, to me, I think the interesting um, thing that India faced is that it didn't have a broader electronics ecosystem. And so it was trying to build semiconductor manufacturing on a very narrow base, whereas Taiwan in the 80s was already one of the centers of the OSAT business, assembly and test business. And so it was pretty easy to ask industry leaders from the US or Europe or Japan to imagine building chips in Taiwan when they'd already been assembling chips in Taiwan. Whereas I think that's the challenge, or one of the challenges that Indian firms faced, is that you didn't have the rest of the pyramid, and so building the top of the pyramid without the rest of the base was just very difficult to actually undertake. And it's still an issue I think India's working through today.
Yeah, I agree with that. That I think that's definitely one reason, in the sense that both Taiwan and Japan, China, even they started from the other end of the supply chain, right? So you do electronics, then you do electronics assembly, then you do chip assembly, then finally you get to fab and then design. India's model is exactly the opposite, right? Like even the when we started doing well in design because we already were had a good software industry. And I think the key difference for this is also that India was not that globally integrated into the supply chains because of the state run model, right? So until 1991, any relationship with the external world was seen, especially imports, were seen as a big burden, because the foreign exchange was really precious. There were strict controls on what a company could import, etc. Whereas Taiwan, you see, right from the 1950s, you have opening up of the markets, right? And even that this precedes even the military rule time. So you already have global integration into many supply chains when this word came in Taiwan, in Japan, and later in China after 1978. But that didn't happen in India until 1991. So it was a very different world. That is one reason. The other reason I feel sort of was important. One reason, as I already discussed, was government run companies had no incentive to compete in this hyper competitive space, which demanded capital infusion constantly and to upgrade technology completely. So even by the time these companies could get a product, their buyers already had good foreign alternatives, so they didn't buy from them and they just faded out. The second reason, and I think there's difference between how Taiwan and India approach this, these were government run programs, so competition was a big problem. So in fact, the two companies that I told you, SCL and BEL, after a time they just said, hey, BEL, you stop making chips, you just do integration, and SCL, only you make chips because we can't afford both of you running, right? So I mean, in the private sector you would have seen competition as a great thing, but in the government sector you saw it as a competition. Whereas in Taiwan, even though there were government led efforts by the ERSO, the actual work was being done by multiple companies and competitors which the ERSO was engaging with, right? So that's why you had competition working for them, whereas that was not the approach here. And the third reason was this inward looking approach, because business policies were difficult, importing things were difficult, there were exorbitant tariffs. So even BL and SCL, in fact, their files are on record that it was very difficult for them to import the machines, etc., which are required for them to progress to the next node. So eventually, they just fell behind in the race, which again was not the case with Taiwan.
I think there's also got to be some like pretty deep political economy factors as to why India never embraced export-led growth. You could hypothesize, well, Taiwan's small, so there's no other option other than export. And I think there's some truth to that. I guess the counter would be China, which is big, and yet nevertheless embraced export-led growth in the 80s, 90s, 2000s. And if you talk about India's challenge with foreign exchange, which totally understand that, one of the potential solutions is to export more when you don't have the foreign exchange problem. And so I'd love to hear you talk about why was it that in as early as the 40s, 50s, India didn't embrace that model, just as Taiwan was moving in a very different direction.
Yeah. So that you have to see from the historical lens of India's anti-colonial struggle, etc. Right. So when independence comes to India, at that point of time, there are two things happening. The World War II has ended, so there are World War related controls which are already operating, and these controls already make things difficult for from exporting, importing both. So there are a lot of trade barriers, etc. And there is this historical experience that you have been exploited by connections with the world, right? So that's why also poverty is very high, etc. So the model that India takes at that time, and that was a at that point of time, it was not pretty clear, right, whether capitalism is the right way to go, which we came to know uh, 15 20 years later. But at that point of time, it was 51-49 thing, right? Some countries like USSR were also growing, etc. So the Indian sort of thinking at that time, political thinking, felt more closer to what the USSR model was, and that's why they just adopted that. So that was the beginning, and like you said, Chris, the one way you would do this is to actually export a lot, and once you export a lot, you will earn foreign exchange. So while that was the thinking initially in the government as well, that yes, we will export, pretty soon they realized that that is not happening because everything was controlled, right? So the instead the fault that they found in is that because we can't do that soon, we don't have great industries already built in, the way we should preserve foreign exchange, the lesson they learned is by restricting imports, not by actually producing exports. So I think those were sort of the pathologies that came in together at that point of time. And it was well until the collapse of the USSR, etc. I think that lesson was still not driven. And of course, China's success after 1978, it required a long time. We made really big commitments into a state-led model. uh, so yeah.
Oh no, it's interesting because Chris, you wrote a whole book about how the Soviet Union, or Gorbachev in particular, was like trying to wake up even into the early and mid '80s, and Dung kind of had the realization in '78, but like that extra 15 years when you are already setting yourself back like pretty dramatically relative to China of what they were able to build over the course of the 1980s, has some pretty long ripple effects. Anyway, sorry, Chris, what were
No,
you
I
going
think,
to say?
I think that's absolutely right. And I think also on the question of foreign exchange, which I totally see how that was absolutely central to Indian policymakers thinking. The Taiwanese had the same problem, but they chose a different method of dealing with it, which was just keep their currency really low, make it too expensive to buy anything for the consumers, and that basically solved their foreign exchange problem and enabled exports to be really cheap. And India had the exact opposite; they had an overvalued currency by a lot of metrics for a very long time. So again, I think going right back to the kind of political economy and ideological aspects that you brought up.
Yeah, actually, there was an attempt at devaluation of Indian currency also, which happened in 1966. So the hope was similar that, South Korea and others are doing it. So can we also try that? But the lesson that the government learned from that, the idea was it will devalue, and after that there will be some collaboration with the US government, etc. For supply of, that time there were shortage of food, etc. So there will be grains coming in. But India and the US governments fell out on that, and somehow the Indian PM at that time felt that they were the US part of the deal was not followed through. And back after 1966, India went full on socialist, so in the model. So until that time, at least there was some thinking But after 1966, you go to a period where this devaluation doesn't work. Remember, devaluation will have some short-term adverse effects, right? When then you will start seeing things going up when exports increase. But we didn't give that time for things to recuperate, and we just went full on socialist after that. And yeah, that's the story.
So earlier, Pranay, you mentioned that sort of the Indian model of development has been, coming at it from the opposite direction of what you saw Japan, South Korea, and Taiwan do. And you are a product of that sort of like software focused development strategy. Let's do the sort of historical political economy of how that strength ended up developing over the course of the 20th century.
Yeah, so that's another very interesting idea. So, for example, because of these controls, large scale manufacturing has insane levels of controls on labor, whether you can hire, fire labor, or the amount of compliances that any company has to go through. These were very high. In fact, in the pre-liberalization era, there were also certain items which were restricted for manufacturing exclusively by the small sector. What this means is that the company had to remain small, and if you actually brought in more capital, machinery, etc., you weren't allowed to do that if you operated in certain sectors. And believe it or not, it started with some really handicrafts, toys. By the 1990s, even electronics was included in it. So can you imagine, you have electronics companies where there were export controls. So that was the period. Whereas for software, etc., and India's human capital story began again in the 1950s, because after independence, it invested a lot in higher education, not so much in primary education, which was the case with China, but there were very good technological institutions that came in. And that was also partly the reason why we did well in space, nuclear, reasonably well. And also we had starting points in semiconductors, etc. Right. So there was this base of people who are technically sound. They had some ideas, and so when the software industry starts coming in, the interesting thing is software firms are not under the industrial regulations. So these restrictions which I told about don't apply to software. They come under the Shops and Establishments Act, which is very different from this Industries Act. So the contracting norms are easier. The restrictions on hiring, firing were much smaller. So that is what starts to become one central point why this takes off, whereas the others don't. By the way, India's software story starts with a semiconductor firm, actually, in the sense that Texas Instruments India was the first
Hmm.
MNC to set shop in Bangalore. In that case, our Silicon Valley is also like the Silicon Valley, which is the OG Silicon Valley, right? So it starts there, and you had largely software work happening in TI India at that point of time. Things related to satellite communication, etc., starting in 1985. Over time, in the 1990s, you liberalize, so there is a lot more MNCs coming into India, multinational companies. In 2000, there's a Y2K crisis, which really boosts Indian software exports. There are lots of work done in India by that time. And then you also see a lot more semiconductor design firms setting up shop there, right? So I joined Texas Instruments in 2003. And by the time I had joined, it was already, nearly 18 years into the game. So by that time already, you had architecture level work happening there. So it was not just back end work, but also, for example, the industry fastest digital to analog converter, etc., was made out of TI India. The Texas Instruments world over, the fellows who are the technical ladder is through fellows, etc. Really, people who have done exceptional work. Outside US, the largest number of fellows that TI had was in India. So again, there was interesting things happening. And then you see many more companies. So Nvidia to AMD, etc., all of them had set up shop there. And all the companies did work at varying level of expertise, right? So some companies did back end work, large number of engineers. They were just taking advantage of the labor arbitrage and the fact that there were a large number of people. But on the other hand, there were also companies which were deeply entrenched and doing architecture level work. So that's what it began with. Interestingly, with all these companies coming in, another segment developed, which was design services. So these were services firms which were providing a, work, providing labor to project specific labor to these design houses of Texas Instruments and AMD, etc. So that is something which is not often mentioned when we see value addition charts of semiconductors, but that is a very big deal in India. So you had large number of people who were providing this services. So in fact, the names you would have heard: software firms, Infosys, Tata Consultancy Services. These are some big software services firms, but they also have hardware, VLSI hardware services. So they do employ people in these design houses. So that was the sort of the next phase. And I think we are in hardware today where we were in software 10, 15 years ago, in the sense that there's a, in 10, 15 years ago, there were no Indian software products, though there were a lot of services and software services. That's where we are in hardware. There is a lot of technical expertise on the design side, but we don't have great products, etc., which are, again, we can discuss that. But those are the things that is the next jump for this sort of industry. So that's where we are.
Is the reason the government didn't restrict software like it restricted other spheres, A, because they just didn't understand? And if they had understood, they would have restricted. Or was it B, that actually the software industry was developing a bit later, kind of in the 80s, when you had the new kind of Rajiv Gandhi, partial liberalization began? Is it sort of a chronological story, or is it just the bureaucrats had no idea software was going to be something important?
Yeah, it is both. So, yeah, like in many places. So it was, yes, partly because it was the 80s, and one of the first papers on the fact that we were following a wrong economic trajectory came out in 1969. So by 1980s, there was already some realization within the government that, this is not the right strategy. So, and like you rightly said, we had already done some partial liberalization in the 85 onwards. So that realization was there. And software, again, was something which, I mean, that point of time, it was so inconsequential that they thought, why to even restrict it. Also, an important factor is it starts taking place away from Delhi, away from the power center, south in the country, in Bangalore, right? Because Bangalore is this place. It is India's most globally connected city, probably even back then, and also had that ecosystem of a large amount of good technical institutes. So IISc, Indian Institute of Science, which is India's best postgraduate science institution, and all these firms which I'm talking about, the technical firms, even the government run firms, the defense, the space, all of them started in Bangalore in the 50s, 60s. So you have this ecosystem building up away from Delhi. So they were like, okay, I mean, the state government here just said, let's just experiment, there's nothing to lose. And that sort of helps take up.
Why is Bangalore the Indian Silicon Valley? So I guess I see story one, which is that they have good universities and technical institutes. That makes total sense. You mentioned Bangalore being globally connected, and was that true in the 50s and 60s? I mean, I guess when I think of the big cities of India at that time, it was like Bombay, Delhi, and Calcutta at the time was sort of one of the big cities, and that's obviously declined in importance. But talk to us about Bombay and its development and why it is the Indian Silicon Valley.
Bangalore's global connectivity starts a lot with the software industry, but it already had the technical sort of chops even before these things started, right? So, because, for example, the space industry, when it takes off here, a lot of people who started the space industry, the initial engineers, Dr. U.R. Rao, etc., were people who had studied in the US and then they came back and started things here, right? So, so I think the crucial thing was this: the contributing factors for creating an ecosystem were here more than in Bombay. Bombay, for example, it's like New York, right? The cost of starting anything is so high because the land is restricted, etc., and we had even more insane regulations. So it just couldn't take off. If you are a startup and you want a small house, you're not being able to afford it easily. So Mumbai was difficult, and Kolkata, Chennai are the other metro cities. But they were also that ecosystem never existed there. So that was really important. And today, if you see Bangalore, it's not, people know it for the software prowess, but it is also India's biotech hub. A lot of biotech things happen. Even advanced manufacturing happens in and around Bangalore. And now I think Foxconn is also going to start things soon on the outskirts. So that sort of helped Bangalore. But the global connectivity, etc., started with the software revolution.
There's also the weather hypothesis, which is that Silicon Valley has the nicest weather in the United States and Bangalore has the nicest climate in India.
Yeah, yeah, maybe. But there are other places like Bangalore which also had good climate. Like Pune is another city which is far away from Delhi, also had good educational institutions and quite good climate. But I guess Bangalore just got lucky on that front.
Well, I think this space connection is interesting because you also have a lot of that in Silicon Valley. The kind of aerospace industry gives rise to the demand for electronics, and so that's an interesting parallel as well.
Don't apologize. No, I mean, I love this, like, the Chinese sort of commercial revolution also starts in the South because we're like far away from Beijing and they just don't really know what's going on. And you can kind of get a lot further before the government realizes that maybe software is this like horrible capitalist thing that's going to ruin our like sad, poor socialist paradise. Lots of fun parallels there.
Yeah.
But does Shenzhen have the best weather in China? I'm not sure that's true.
No, it's too hot. It's really hot. So Pranav, I want to do just like a little day in the life of a chip designer. Like, what is it like? What do you wake up every day and do? At a firm like TI or Qualcomm.
Yeah. So, I mean, the chip design itself is a word that you would use outside the industry, because if you go inside the industry, there are 35 versions of chip design engineers, right? So, there are some people who would be doing the really architecture level work. And I'm talking about the digital side. Analog has its own terminologies. But on the digital side, you will have an architecture team, you will have a verification team which will analyze whatever the design has done. Does that work appropriately or not? And then you will have a design for test team which will actually put in structures onto the chips which are then tested when you realize it on silicon. And it tests all the ideas about whether, if you say your chip is going to work at 1.2 gigahertz, does it work or not? You don't do that through verification checks only. You have specialized structures within every flip flop in a chip that are put in to do this kind of testing. So I was part of the design for test team. We did that kind of work, but there were others who were doing verification and design level work as well. So this
So
the DFT thing was interesting because, unlike other two segments where you're largely working on the computer with the EDA tool, with the design for test idea, once the die is actually fabricated, you also get to play with it and you also get to test it in a testing facility, in a fab, or etc. So we had a small low cost tester also on site. So we saw the die and we did the speed binning of that chip, etc. also. So that is the kind of work it happens. But a day in the life would generally be, you are working on one project. So it could be, let's say, if you're working on a mobile phone processor chip, there will be one team which will be working at the processor level stuff, and others will be designing smaller IPs within that. So some teams will be working on the graphics part, some teams will be working on the USB part, etc. So all the smaller teams work to optimize the IP. Each of them will have their own design, verification, and design for test teams. And all of that sort of, it's like modular, right? So all that happens, then the processor level team integrates it. There are lots of work on the computer, lots of meetings and very interesting things during the tape out times, because there are fights between teams. This didn't work because your part didn't work appropriately, and so on and so forth. And yeah, I think that's how it works.
Could I ask, what does it take to be a good chip designer?
Yeah, I think the knowledge of core fundamentals really helps. So, for example, digital design is very abstracted, right? So, you don't necessarily need to know how a transistor works, but as long as you know how the model works. So, that works fine to an extent. But once you have to do this kind of, for example, when you have to do testing and you have to really debug out of a million transistors, what part is failing, that it is not working at 1.2 gigahertz and it's working at 1.1 gigahertz. That if you want to do that level of work, you need to have really good understanding beyond that one level of abstraction. You need to know what is the transistor like, how what are its features, why are some things, what are the some things that can go wrong, why leakage currents are high, etc. So really good deep knowledge of analog design and analog circuitry can be a big boon in this industry.
Um, so you sort of alluded to this of like there's like a value chain within the IC design industry. I mean, maybe Pranay, if you could like talk us through, what is the relationship between I don't know if we should do like Nvidia or Apple or like, you say like the M2 chip, like what ends up happening in Cupertino, what ends up happening at ARM, like and what ends up happening in India versus California, maybe when you're thinking about going from an idea of a product to the silicon that you'll need to make it.
Right. So let me talk about it from a Texas Instruments example. They used to
Sure.
make this processor chips, which used to go into Android phones. And these are processor chips which were made by, it was a OMAP series of processors. It's discontinued now. So the way it would work is that first, these teams would first decide, what is the specification you need in order, so they would have some deal with, let's say, the OEM side, right? So Samsung has spoken to Texas Instruments that they want this particular specification that the processor should meet, or this is the speed. So there are all these benchmarks, right? Speed benchmarks, leakage benchmarks, etc. So those specifications would be given, and then a team would be formed to realize this on the chip. So then there will be an architecture level meeting where you will actually think and brainstorm about what will be the components that will go into the chip if you want to meet those specifications, right? So what kind of ARM processor do you use, what kind of graphics accelerator do you use, all that is debated, brainstorms, and probably you experiment with a few things on simulations, etc. So once you have confirmed that this is sort of what components that are going on, there are already built IPs that you just license from likes of ARM, or there will be some suppliers of USB connectors or of graphics, etc. as well. So the way, for example, we used to do is the graphics accelerator used to come from ARM. Also, the processor blueprint used to come from ARM. So you would then get those things in, and then the integration teams, etc., will start working on them, and then they would really start to put these things together. So all the, as I said, it is modular. So first, at the level of the subcomponent, you will do all these steps, confirm that it is working absolutely flawlessly, and in parallel, people are working on other components. And at some stage in the V0.8 or V0.5 stage, you bring in all those components together for the processor level design, and then you again run some initial level tests. You will come to know what are the problems, are this is this speed enough, is it not? So then you need to replace all these subcomponents, right? So let's say the processor is too far away from the graphics accelerator, and that is causing a lot of latency. So the place and design team, there's an STA team which tries to work on this and bring things together. And once that is done, you run a lot of verification tests at the full processor level, confirm that it is working, then that is sent for tape out. You do a bunch of more testing there. There is another application engineering team which keeps interacting with the OEMs, and these AEs then sort of test these chips with the OEM and see if it is working at their end, at that level of abstraction as well. They come back and give feedback. and so on and so forth. This is like a back and forth. There are lots of back and forth things which happen. One important element that I didn't mention in this, during the place and route stage, right? Once you have the RTL level, the design level work happens, you also interact a lot with the foundries, because the foundries would have specific libraries they will give, right? So there will be a TSMC 28 nanometer library. So you are invoking that library, and that library has characterizations of the delay of each flip flop or the power that it requires. All so those are there in the form of files, right? Those files you take in and you run all these tests, which I said, delay test, speed test, using that characterization which is provided by the library. So there's a one form of connection which happens with someone at Texas Instruments will be working closely with the TSMC folks, seeing if that library is the best one or if there are changes required, so on and so forth. And of course, all this happens through EDA tools. So we're generally using one of the three. Back then, Mentor was also a big supplier, but other than that, by 2012-13, I just saw Cadence and Synopsys being the two big players which were using. And they supply EDA tools throughout the supply chain. So they have a separate product for doing the verification, separate product for architecture, separate product for design for testing, separate product for layout and delays and static timing analysis. So these are very big players. They also interact a lot with the foundries to optimize, because as I said, you don't have the chip, you only know how a transistor works by characterizing it as finely as possible. So they work a lot with these foundries to characterize it very, very finely, so that you're able to not see surprises after your chip is out.
So, in all of this design work that happens, like where is the biggest, value add? Who makes the highest salaries? And how does a country like India end up slowly like gaining on that value chain internal to IC design?
Yeah, that's a cool question. So I think the first level of work, which is sort of simpler in this, is the placement, routing, the timing analysis kind of work, which is at the end part of the design segment, right? So that is when you already have all these flip flops and things laid out. You don't have any uh, you don't require a deep understanding of what exactly that chip is doing, but you just need to ensure that the timing, etc., which you wanted to meet, delays, etc., are being met. So that is at the lower end of value addition. And as you go up the supply chain, the sort of value addition keeps increasing. So obviously, architecture level is the most high value add segment, even within IC design. Even design for test, because it is also some part of design, is probably at the second level. Verification is probably at the somewhat the third level, and then finally placement, routing, etc. So this is how the value addition happens. Like I was mentioning earlier, a lot of companies in India do the placement, routing, etc. And when I said that much of the work is also outsourced to design services firms, the work that is generally done is either in the placement segment or in the verification segment. So but a lot of the in-house design work now, for example, would be done at the higher end of the value chain. So um, and I've seen it working differently in different companies. Some companies get comfortable working in India, so they are more comfortable to give architecture level work. And some companies hold that tightly with the mothership, and they give only, let's say, placement level work into the design houses here. So it varies, but as you can see, it just happens with time. So but the value addition is definitely highest at the architecture level.
But so your thesis is that like in 10 years, there will be sort of Indian brands that are doing the work that Qualcomm or Nvidia is doing today, because it's just a matter of time before you march up the value chain. Is that basically right?
Yeah, I think I would separate it to, if we are talking about the competence required to make that kind of chip, that exists even today, and it will definitely exist in 10 years time. So because there are people with 25, 35 years of work ex who have gone out of these companies and started their own firms, right? So a lot of the design services firms I told you are started by former employees of Texas Instruments or Qualcomm. So that kind of ecosystem already exists, but there's a big jump from you knowing what to design and then realizing it in the form of a company, right? So you need to have a product idea, you need a venture capital ecosystem, you need venture capitalists who understand that what kind of this industry is, that the fact that it has long gestation periods, etc. So that is where it will take time. So the question that remains to be seen is that whether we'll have that in 10 years. My belief is we will. But will we get, say, an Nvidia level expertise, etc.? Depends a lot on these factors, right? Are we able to support some of the startups? And also, there's a difference, right? Software firms have a lot of venture capital flowing in India, but that is the ecosystem which exists, and many venture capitalists are very happy funding the next version of Amazon or competitor to Amazon kind of products. But to invest something which requires 5 year, 6 year gestation periods, that hasn't happened yet. We have only seen very small number of companies which are doing fully Indian intellectual property generated products. But that's what will determine whether we can actually match up to the likes of Nvidia, AMD or not.
Yeah, and it's interesting, like what would help that process is not one or two more IITs or like more PhDs. It's actually, a VC infrastructure and ecosystem that would fund it. Plus, it sounds like maybe another way of putting it is that you also need people who can combine the technical with the sort of business and product market fit know-how, and that's the other part of the, um, that's difficult to develop. I think that's the challenge.
Yeah, absolutely. That's a great point. The PMF, product market fit, etc., is a big challenge. So the good thing is now people in the software sector know this, right? How to do this. So and there's a lot of connections of the Indian chip designers with people in the Silicon Valley, etc. Also in Japanese firms which have set up shop here, or Renaissance, etc. Those kinds of connections exist. So I have seen a few buyouts from, say, Renaissance, etc., happening now of Indian IP companies, but it's still a small number. So it requires a lot of that to happen. And also, we should remember a lot of it will happen through exports, right? So finally, the market for even a good designed Indian product will be largely the US or Europe, right? So that is important connection which needs to happen. So you need founders pitching to customers in Europe, US, etc., like it happens with software, not just targeting the Indian domestic market.
So, I think there's a lot of obvious similarities between software design and chip design, which we've talked about. And India has good ecosystems in both. If you look at China, China's got very capable chip designers, as Huawei's mobile unit demonstrates on a regular basis, but has hardly any successful software firms that have sold in the export market. Like enterprise software in China has just gone nowhere. And I'd be interested to hear, and this is more of a China question than India question, I guess, but why that might be. And I don't know, Jordan, you might have thoughts on this too, but it does seem like a puzzle why you'd be good at one and not the other.
Yeah. What do you think, Jordan? Then I'll come in.
Oh no, Pranay, come on. You know some Chinese too.
Yeah.
This is your
Yeah.
show.
Yeah.
What do you think?
Yeah, no, I think actually, if you look at some of the initial papers, Douglas Fuller, etc., had written, even by 2014, it done an analysis of India's chip design firms and China's design firms. So India's design firm capabilities were far ahead of Chinese technical capabilities, even back then, because a large number of MNCs setting up shop, technology transfer happening, etc. So that edge was there with India, but of course, China has caught up a lot now over the last 10 years, b- uh, going backwards from electronics assembly, etc., and climbing up the value chain. Uh, in software, I think one crucial thing is because software began with this notion of exports and it was tightly coupled with the global ecosystem. it was never like the semiconductor story where it was started by government firms only supplying to government, right? The vision always was that you have to supply to the best in the world. That was one really important element, which was not the case in with China, right? And the other thing in software, and the other thing was knowledge of English, knowledge of that was also a really important element too. So that's quite comfortable for people to work with this. We have a running joke in Bangalore that when you folks have holidays like the Memorial Day, etc., there is less traffic on our streets. So very few people. That's the kind of connections which exist. I think that probably wasn't there in China. What do you think, Jordan?
Yeah, I mean, I think it sort of comes back to like the beginning of our conversation. If you're gonna go for a like export led manufacturing heavy approach, like the sort of integration that you need with the world is at a different level than if you're gonna be on the phone with folks and doing, customized like consulting projects to help them fix their IT systems or sales processes or what have you. So, obviously like China had to understand what the world wanted to buy at some level, but I think um, it was a path of least resistance for a lot of reasons that we talked about, not over this show and others to do that by selling things as opposed to selling services. And, Pranay, as you very ably explained that like the selling things was like made really difficult for like a lot of, in retrospect, dumb reasons that, India was able to invest in and build off of the sort of, cultural legacy that you had from colonialism and the educational interactions that you had between India and the English-speaking world to kind of build a more services-oriented thing. But it is funny that we're still here even in the 2010s, and like you don't have Chinese like SaaS startups that are taking over. And I think there's um, a larger puzzle of why Chinese firms are just not interested in buying software like in between each other. Like you've seen some sort of business oriented stuff with like Alibaba and even ByteDance trying to make like a Slack clone, but there's not like a Salesforce parallel. A lot of the, biggest 20 firms, if you sort of go down the list of like what are the software enabled companies in the US and India that have really popped over the past 20 years, it's just like it's all, run in China internally on like what I'm sure is like shitty, but like good enough software, I guess, if you're a manufacturing firm. Yeah, I mean, I've read like random articles of people saying like Chinese firms don't like to buy software, so it's like hard to get started. But there's like a few levels down explanation of why that is the case. Anyways, if you actually have a good answer to this, if
Yeah.
you're a frustrated like Chinese SaaS investor or founder and would like to come on China Talk, do reach out. Jordan at ChinaTalk.media. Um, let's close then talking a little bit about the future of chip manufacturing in India. So Modi has decided to do his own little CHIPS Act. We got $10 billion coming down the pipeline. And there's this real hope, I guess, that, some of the sort of, coming wave of Chinese low end, sort of lagging edge manufacturing when it comes to semiconductors, India, in parallel to Vietnam and Malaysia, may be able to end up trying to compete a little more aggressively in that space. So, where are we now? And what is your sense of the prospects and challenges of India building a real fab industry?
Right. Bottom line upfront, I think India will have one fab. We're probably doing 65 or 40 nanometer kind of, say, analog or some specialized fab, CMOS fab. We might get a couple of compound semiconductors fab, and definitely a handful of assembly level plants. Micron has already started, but you might see that happening. So I think that's how what I foresee in the next 4 5 years. And if I'm wrong, someone can remind me after this 4 5 years. But so let's going back to why I say this, right? So before this version of what this government is trying, we have to remember like after 1991 there was a new effort started to actually do things on the fab. So that version 2 is what I call the unease of doing business in India, right? So a lot of restrictions went down, private capital was welcomed, but yet you had this period where just doing business was difficult, tax policies were cumbersome, we didn't have a single rate of tax. So India was many different tax markets. We had one tax regime only in 2015-16. So there were tax restrictions, trade. There were still, restrictions on imports, not always welcomed, especially if they are non-consumer goods, etc. So there were those kinds of things which still existed. So in 2006, there were a few attempts made. AMD tried to invest in a fab city in Hyderabad. They wanted to start an OSAT plant, but then you know what happened with AMD. It just changed its own business model. Also, 2008 happened, the global financial crisis, things went down. In 2014, there was another wave where again the same conversation started. And in fact, two consortia did apply. One had Tower Jazz as one of its partners. The other one had STM and Silterra as its partners. But again, they failed. None of them could go through because, again, there was generally this fear that doing business with a long gestation period is difficult. We also had during this period a retrospective taxation case, which on Hutch and on Kane Energy, which was really, it spooked a lot of investors and foreign investors because imagine if you can be taxed for something going back in time, why will you invest in something like a fab which will only produce the first chip 3-4 years down the line, right? It's going to be very scary. So those are generally the unease of doing business was one reason why this phase didn't work. So now when you come to the latest version 3.0, what I call, the government has tried to attempt to mitigate a lot of these things. So what are the new things now? One, the tax policies are far more simplified. India is one tax market now. Ease of doing business, I don't think it's all sorted, but we are on the right track. We have much better, more sensible business policies. Setting up large scale manufacturing is easier. The third biggest reason is national security considerations, right? So till 2010, India's the adversary in the mind for all practical purposes was Pakistan, right? The China threat was there, but it was in the background. And because Pakistan was not as powerful as India, in at least in these technical spheres, there was no sort of what Mark Taylor calls creative insecurity, right? There was the idea was, okay, we can manage these folks by having better defense and better presence on the borders, etc. But when the security situation between India and China fell through after Xi Jinping came into power and things that happened in 2015, 2014, and then 2017 and 2020, the overwhelming mind space of India's main adversary changed to that of China. So all sectors always are thinking about China, and if everyone realizes that China is ahead in the technological game, etc. So that has spurred a lot of attention towards R&D, towards the kind of sectors that we are talking. Otherwise, no one would have thought of semiconductors. No one in the National Security Agency would have ever considered semiconductors, right? It's not a topic worth their time. But now everyone is. And last 3-4 years, I'm seeing everyone wants to discuss this and knows that the importance of this. So that was another important element which has led to the government launching a policy which goes across the entire value chain. Earlier, there was just piecemeal focus on some segments, but now there are incentives. You would have heard there's a $10 billion fund, etc. Right? But that is split into various components. There are separate programs for the design segment, separate programs for the fab segment, and for the assembly, compound semiconductors, and display fabs. So there is a focus on all these. My complaint is actually the priority is wrong, but it is in the right direction, but priority is wrong. We are too focused on reducing import of every small chip or product from China, which I don't think helps us in the long run. And in fact, we should be prioritizing doubling down on our comparative advantage, which is design. So the program design currently is not that way. And I think it should be. So that's where we are.
Could you talk about, I think one of the trade-offs that India faces is that on the one hand, I totally see the logic of doubling down on design, comparative advantage. That's where the value add largely is. On the other hand, I also see the argument that India has a whole lot of people it wants to employ. Manufacturing is a great way to employ large numbers of people. And not only at fabrication, actually less at fabrication, but at the assembly and test and the device assembly level. That's that's a segment where you can actually create a lot of employment in ways that are probably productive of higher value add over the long run, sort of what China's done over the past 20, 30 years. So how do you, A, am I categorizing that wrong? And B, how do you think about that choice?
Yeah. See, actually, India's labor problem is so huge that semiconductor assembly is not even going to solve a small percentage of it, right? So we have 12 million people entering the workforce every year, right? These are just people who are turning 18. So even if assembly, all of world's assembly happens here, it's going to be a small dent on that number, right? So uh, if you want to solve that problem, there are a lot of production linked incentives that the government is working other labor intensive sectors, right? So textile is again one thing where India did have a export advantage as well, but it has been overtaken by Vietnam, Bangladesh. So there's a lot of energy in trying to get those up. But semiconductor assembly, etc., is not for the employment thing. The reason why we should do fabs and assembly is to reduce vulnerability, right? So you need to have the basic knowledge of making the core element of the information age today, right? So the idea is you want to invest in this so that 20, 30 years down the line, you might have some capabilities which are really, really significant. But at this stage, it's just, reducing vulnerability, learning how to run a big manufacturing plant, learning how to run the things of the kind of purity levels in chemicals, etc., which are required for
But
semiconductors.
could I
So
ask, like,
I would put
say this, so if you had like, either the Taiwanese or the South Koreans or the Chinese, they would say, yes, obviously semiconductors or electronics writ large can't on their own make a major dent into the employment question. But, if you called up the governor of Guangdong province, I think he would probably tell you that that was absolutely critical to both providing employment, but also, moving up the value chain over the last 40 years. And so I do wonder whether solely focusing on the vulnerability side, I mean, does that miss the ladder that all of India's neighbors have, or many of India's neighbors have been climbing over the last couple of decades, going from, the 3 million people or however many work at Foxconn and others in China assembling iPhones to then providing the demand for the components that go into iPhones and then learning how to produce the chips that go into iPhones. It seems like that's a well-trodden path. And so why isn't that also relevant for India too?
right. No, so that is happening now. As you know, like 15% of iPhone production by 2026 will be out of India. So in electronics assembly, it is definitely happening there. And as I said, the production linked incentives, which are essentially industrial policy to encourage all these companies to do assembly in India, is already happening. And that's the out of all this industrial policy is happening across 14 sectors. And the only sector where it is reasonably good success is on mobile phone assembly and manufacturing. So that is definitely happening at the electronics assembly level. But what I was talking about, chip assembly, there is focus, reduce vulnerability, start building, but not so much from the employment angle. Because, for example, the Micron plant, it will employ 5,000 people at best. Those are the estimates. So 5,000 is a small number from the perspective of even a state government of Gujarat, right? So yeah, they are looking at it from this that okay, we need to build this industry, and this is one place where we can start. Unlike in the past two attempts, we didn't have the OEMs at all, right? You didn't have the demand coming out of India. Right now, you have the beginnings of electronics assembly, so you can also have uh, a Foxconn plant which would require not the processor chip, but let's say some low cost chips which can come from a fab which is sets up shop in India. So that is beginning to happen, but not so much at the chip assembly.
Um, so how would you compare IC design to writing about the geopolitics of technology?
Haha, yeah. Both were fun at different points of time in life, I guess. But in this geopolitics of technology, you can't close yourself to any segment of knowledge, I feel, right? Like you need to know some part of economic reasoning. You just think of it in this conversation also. We've touched macroeconomics, history and a bit of exchange rate management and technology. Whereas when you're working in IC design, the focus is on getting deep. So the depth of knowledge matters, not so much the breadth. Whereas in public policy or the geopolitics of technology, I think the breadth matters much, much more than the depth. And that's how I would put it.
Maybe one more question, Pranay. Like you also host a podcast in Hindi. Can you tell me a little bit about the Indian podcast ecosystem? What does it look like?
Yeah, that's a great question. So, uh, in India, podcast is still a very elite thing in the sense that what is more popular is YouTube channels. So, I mean, YouTube channels get millions of views. That YouTube podcasts they are called, but the audio form is not has not been that popular as a YouTube channel because data is really cheap in India. So if you just go and see any person whiling away their time in a bus, they are watching YouTube videos most likely, right? So, but podcasting ecosystem, our aim was ever quite a few things happening in English, but India has so many more languages, and we wanted to bring very high quality conversations in a language which is other than English. So we started with Hindi. We get around 40,000 listens a month, but that's the only thing my parents listen to. So that's the only part of my work that they know. So that's why I keep doing it. But it's great, fun to talk about these issues. Like unlike in China, Jordan, like you have a vocabulary where all the things when you're talking about a semiconductor podcast, probably you will be just talking in Mandarin, right? And you will have a word for every little thing, probably like even for extreme ultraviolet lithography, probably. But that is not the kind of thing which happens in India, right? Our language of communication for anything technical, anything related to governance policy is always English, not one of our other languages. So for us, the challenge is to simplify things and explain great conversations in a language that common persons can understand. So that's a learning experience.
So sorry, it's not just that. Well, I think you'd be surprised actually. Like a lot of the Chinese tech podcasts, you end up seeing a lot of English words sort of thrown in for the most technical stuff. But I guess you were making a broader point about like the language of policy and politics is by and large English, not dialect in India, right?
Yeah.
Um,
Okay,
Chris and
cool.
Pranay, thanks so much for coming on to ChinaTalk.